Hi guys, good morning. Welcome to week 5 of Introduction to Programming course. We are going to discuss today Introduction to Functions, and this is in chapter number 6 of your textbook. We have already discussed about several things, so I hope you are getting comfortable with programming language, with C++ programming language if you have not gone through any programming language before. So we have done quite a lot up till here, so you should be proud of yourself. You have done an excellent job reaching here. So we have talked about logical operators and repetition, different loops in last lecture. So we talked about while loop, we talked about for loop, then we talked about do while loop, and I've given you an assignment as well, and I can see a lot of students approaching me discussing assignment, so I can see that there is progress in assignment. So please make sure that you submit your assignment on time and do not miss any deadline. We have already talked about control statements, which were if-else statements. Then we talked about switch statements as well. So I hope you guys are comfortable with both of these control statements, repetition and the decision statements, if-else statements, because these are the two foundations which have to be very strong before we actually move further, because these are the things which you're going to keep on using throughout this course, and if you go into industry as a programmer, you're going to use them every day. So make sure you understand the concepts of these control statements properly. You know what logical operators are, how to compare statements in if statements and switch statements, and if you are comfortable with them, then you'll be fine with all the coming topics in this course. So as I said, today we're going to talk about functions, and we're going to see what functions are. And obviously this Friday is going to be a lab exercise. I have already announced on Blackboard that we are going to have a lab session this Friday at 8:30 in the morning. That'll be for 1 hour. So just like the previous lab session we had, I'm going to give you a task and you're going to complete that task in 1 hour, and during that lab session we'll have a QA session. So make sure you go through today's lecture very carefully. There are several exercises as always. So since this is a practical course, so most of the time I'll be spending on explaining you the code. I'll go through the slides as well for some diagrams, for some explanations, but most of the time I'm gonna spend on our code in Visual Studio. I hope you guys have already installed a proper IDE for yourself for C++. So if you are still using an online compiler, fine up till now, but as I always recommend, it's better to have your native IDE installed on your computer. It will give you more flexibility, it will give you more control over your code. So make sure you do that if you have not done it up till now, because there is a project coming up and it might require you to access some files from your local computer. So better to have something installed on your computer. Alright, so let's get started. We're going to talk about functions today. So let's see what functions are. I'm going to just explain very quickly what functions are, and we're going to move to our implementation in our code to see how they actually work. Well, functions are basically small portion of your code that you can reuse, right? And I'm going to show you how you can reuse. We have already used some functions like main. Main is a function, and I'll explain what that means. And there are some functions that we have used through libraries. For example, if you remember, we've used a square root function in our previous week, and we have used a find function from string also to find if the vowel is included in that string or not. So we have done those functions. So those functions which are available in our libraries, they are normally called built-in functions or library functions, right? So C++ and many other programming languages, they have a lot of functions readily available for you that you can use in your programs by just including the libraries and calling those functions. But there are needs where you have to create your own functions to do several other things. It depends what are the requirements of your project. Those functions that you create yourself are called user-defined functions. So there are some built-in functions, library functions, or we also call them pre-packaged functions, and there are some functions that as a developer, as a programmer, you have to create yourself. We call them user-defined functions, right? So it'll be better if I write a code for you and then explain the code to you. So let me do that very quickly. So I have this blank window in front of me. I'm gonna create a program, very simple program. Let me include all the libraries using namespace std int main and return 0. All right, so this is what we have. We have included a library, we have used a namespace over here, and then we have created the definition of my main function. So if you remember, we used to call this a function, right? And main is a function. This is where your program starts. So compiler is always looking for a main function to start your program. If there is no main function, compiler will still compile your program, but your program won't be able to start because there will be no main function. So if you see, we are using the keyword function again and again. Main function, main method, we are always using that, right? Now this is a function. Function is something that does something, and we can reuse that. Right? I will come back to main function in a while, but let me start with a scenario where I want to do something and I want to do that thing again and again, right? So what I want to do is I want to display some messages. So I'm gonna say hello world, and I'm gonna display some other messages as well. So I'm gonna say welcome to C++, and I'm gonna say I'm learning functions, right? So we know that if we run this, we're gonna see some statements displayed on our console, which is expected. So that's a normal flow of a program. Fine, we haven't done anything magical right now. So this is what we do, right? Very simple. So maybe we have done some calculations over here. Maybe we have created some variables, int I comma j. We take maybe this value from user, something like that, and then we want to display these three values, these statements once again. We want to do this again. So what we have to do, one way is to just copy them and paste them over here, right? Fine, it will serve the purpose. And then maybe down the line we might need these 3 lines again. It's not very practical, just want to give you an example. So we might want to use this again and again and again. So what we have to do is we have to copy paste this code again and again and again. It's the same code, there is no difference. We have to do it again, right? So how about we create a function and we put this code in that function and we just keep on calling that function. Don't worry if you are getting confused, don't worry, it's absolutely normal. So I'm going to explain that to you. So the problem which we are facing right now is, if I want to use these 3 statements again and again and again, I have to save them somewhere and call them from there, right? Instead of just copy pasting them again and again, right? Now some of you might be thinking, why don't we use a loop, right? Why don't we use a loop? We use a for loop and display this again and again and again. But for loop, what it will do is, if I put a for loop or a while loop here, so if I do something like this, let me take this up. If I do something like this, starting I with 0 and doing I is less than 10, for example, and putting this in a block of for while loop. So what this will do is, it will print for me these statements 3 times each. I mean 3 times it will it will print this 3 times on the first run, then 3 times again for the second run, and so on and so on and so on. But the problem is, I said that what I want to do is, I want to print them now here once, all 3 statements as a set once. Then I want to write some code over here, whatever code it is, cin, adding some numbers, and then I want to go down here and want to print them again. So this while loop is not going to serve the purpose, right? It's going to print all of them together, right? All of them will be printed together, and once it's printed maybe 10 times or 12 times, then this code will run. And then if I want to print these 3 statements again, I have to run this while loop again over here, right? But this is not what I want. I want my function, I want these statements to be called again and again wherever I want them. I don't want them to be done together in one set once and then twice and then thrice at one place. I don't want to do that. While loop is going to print this for me once and then this statement will be executed, right? I don't want this, right? I want to put them somewhere and then I want to start using them so that I don't have to write them again and again and again. I will show you now what I mean. When I solve this, you get to know what I'm telling you about. So what I'm going to do is I'm going to put them in a special container which is called a function, and I'm going to call that function. Simple, right? So what I'm going to do is I will create a function. Let me call it void. I'll explain everything. Just let me write it first, show you the display, and then tell you how I solve the problem. So I'm going to put this over here like this, and I'm going to call this again, right? So I'm going to call this, let me take this here and let me run this program. It will print for me again. That is fine. I'll explain what is happening. And then after doing this, what I do is I created some variables. I took some cn, maybe I, and then I want to display these three statements again. I don't have to copy paste. I'll just call this again. I'll just call this method again and it will work. Then maybe I'll do something else. I'll just take an input in the form of in j, and then I want to display this function again. So let's see what happens now. So it displayed three of these statements. Then it's asking for a number from user. So I'll enter 10. Then it displayed the values, three statements again, asking for j now. Let me put 8 over here, and then it will display those statements again, right? So this is exactly what I was looking for. I wanted to display these statements again and again and again wherever I require them, right? Now this I cannot achieve using while loop. Well, I can achieve using while loop, but that program will become very, very complex, right? So I'm not going there. I want to keep it simple, and I want to at the same time display this again and again and again in the middle of my program wherever I want, right? It's not very practical right now, but there are going to be cases where you need to have these methods called again and again and again, right? So what I did is I took a container, I created a container. We normally call this container in C++ as function or a method, and I placed those three statements inside that method or a container. And what I did in the main method is I just called the name of that container, and whatever was inside that container, it was displayed by the compiler, right? Then I did something else. Then I called the name of that container again, and it was done again like this, right? Did something again, call the name of the container again, and container displayed those statements again, right? So this is what I did. Very, very simple. All right, let me just get rid of all of these things and let's explain what is going on over here. So in order to explain this, what I'm going to do is I'm going to go back to my slides first, and let me show you how a method looks like. So this is what I'm trying to tell you. These are all the things, and we will discuss all of these things again and again. But let me quickly show you what a function looks like. So a typical function in almost all the programming languages, it will look something like this. So it will have a header. It will have a header, which is this is the header or definition, or sometimes people call it signature as well. So we normally call it header. So this is the header of your function, and then the header will have a body. So after the header, the function will have a body starting with these curly braces, and inside this we'll put a statement. So we have a header of a function, and curly braces start, curly braces end. Within the body of this curly braces will be the body or the details of that function. Whatever this function is meant to do, we write all those statements inside, right? So this is what is happening. So we have a header for a function, and then we have a body of that function. Now if you see in the header is further divided into few things. If you see over here, it has something like this. It has a name, then it has these parentheses. So what are these? So if you see over here, this int or void, the first statement, int or void or whatever data type you want to put over here, it is basically the return type, what this function is going to return, right? Just like if you see the main method, if you compare the main method with this one, it has almost similar things. So main method has, because it's a function, main is also a function, display is also a function. So what it does is, main method, it has a return type. First of all, it has a header, and then it has a body, right? So just like display, it has a header and then it has a body, very similar, right? So that's why both of them are called methods. Then if we see the header closely, it has some return type. It can be any data type in C++. It can be any data type, right? Now integer is a data type, float is a data type, double is a data type, string is a data type, then we have Boolean as a data type. So it can be any data type that C++ offers, right? If your function does not want to return anything, so if you see that I have put int main here, which means that whenever this function concludes itself, whenever this function is completing its execution, it should return something. And what it should return? It should return an integer. That's why you see a keyword return and you see what it returns. In this case, return is a keyword. Returns means this function has completed its execution and it wants to return something, right? And it's going to return based on this data type. So if this is an integer, return should return an integer. 0 is an integer, right? If I had a string over here, so then it should return a string from here. If I have a float here, it should return a float from here. If I have a Boolean here, then it should return true or false, Boolean value, right? So return will remain return, and it will next to return will be some value that is of this data type, right? So in this case, since integer data type we have, so return will return a 0. And after the return statement, we do not have anything in main, right? Normally there are scenarios and we will discuss those scenarios, but normally, just to say now, that return statement is normally the last statement in your function, all right, in your function or a method, unless and until you have some control statements, right? Okay, so if you don't want to return anything, you use a method, you use a data type void. Void data type means nothing, right? So if you see in our function, we are not returning anything. We are displaying something, yes, but we are not using any return statement like this. We are not doing that, right? Why we are not doing that? Because our function has a header that contains void inside it, which means that function is already telling from its header to anybody who is calling this function, we'll talk about what that is, that I'm not going to return anything. Do not expect me to return you anything. I might do my function of, in this case I will display something on the console, but I'm not going to return anything to you so that you can use that. But we will create some functions today where we are going to return things as well, all right? So this is a return type. If it's a void, it means that your function is not going to return anything, and if you're going to return anything with void, you're going to get a compile time error. Compiler will say your header or your definition says that you are not going to return anything, you are using a void, and then you are using a return statement inside. No, you cannot do that. Similarly, if you are using a return statement, if you are using a data type other than void and you are not returning anything, you are going to get a compile time error telling that you said that I am going to return something, but you are not returning anything. So this is very important for you to create your functions in a way that you don't go against the rules of the programming languages, which is in this case, since you are providing the definition of your functions using a data type, you should return something. If you are not providing in your functions definition any return type, then don't return anything. So for example, if I return from here 0, and if I do something like this, you're going to get an error, right? And the error is going to say return value type does not match the function type, which means that again, that you said this is going to be void. Void means you are not going to return anything, and then you are returning something. You cannot do that. So compiler will give you an error over here, right? Similarly, if you do something like this and you try to run this, it will definitely run over here, because in the background it is returning. So what is happening right now is your main function, what it does is your compilers are becoming very, very smart these days, right? So some of the functions that are required to return something. If they don't return anything, compiler automatically in the background return something to the operating system. So main is a method which is going to return something, but if it doesn't return anything, compiler in the background will automatically return something 0 or 1 depending on 0 means that there is the function or the method worked successfully, executed successfully. So 0 code means that it ran successfully without any error. If you provide anything else, it means that it ran with an error, right? So in this case, these days compilers are becoming very smart, that in such cases compiler will automatically put a return statement for you. I mean, you as a programmer you won't see it, but ultimately they are returning something to the operating system, telling operating system, okay, programmer might have missed that, but I am definitely returning that, just to make your programming as a programmer more efficient without giving you any errors, right? However, if I do int over here and I try to do something like this, I will get an error, right? I will get an error saying that display must return a value. Since this is user defined function, if I mention over here a data type, return type, and I don't return anything from here, I'm gonna get an error, right? Because this is my user defined function. Main is an automatic function. Main is a special function that is going to start your program. So if you miss a return type over here, it would still work, right? But in complicated programs, if you start changing these data types, it might not work. But in a simple program like this, even if you don't specify any return type, it would still implicitly provide, compiler will implicitly provide a return type, return statement for you, which as a programmer you won't see, but it will be there, right? But it's always a good idea when you are even creating your main function and you're using an int as a data type, as a return type, make sure you provide a return statement over here. It's good programming practice. It's more readable as well, because if some programmer sees something like this, or maybe if you're using an old compiler, you are not using modern compilers, you compile your program with something, I mean, way back 5, 6 years, 7 years back, you might get an error, right? The compiler will say, what is this? You are saying that I want to have a return data type, but you are not returning anything. It's an error, right? But modern compilers for main function, they treat main function as a special function, and they fix a lot of problems on their own. All right. So this is the return type in the function. So as I said, that return functions in their header are divided into multiple things. So this is our header. The first thing we talked about is a return type, and it can be any data type. The second thing in the heading of a function is the name of a function. So it's displays the name of function. You can name it anything you like, you can call it name, you can call it UFV, you can call it CIS, you can call it anything. So all of the rules that apply on creating a variable apply over here. So you cannot say this, right? You cannot name your function starting with a numeric number, numeric value, right? So it can't be a numeric value. Starting with 1 or any other numeric value won't work for your function names, just like it won't work for your variable name. So I can't do int 1, right? Int 1, I can't do that, right? So same rules that apply on creating the names of the variables apply on functions as well. So same thing, you can't do that, but you can definitely say that function 1, it will work, right? So you can still have numeric values, but you cannot start the name of a function by a numeric value. So just keep that thing in mind. Okay, so second thing is the name of the function, right? Name of the function, and this is what we saw over here. So first thing is the return type, second thing is the name of the function, and obviously it's a user defined function name. It can be anything you like, but it cannot start with a numeric value. All right. Then we have a parentheses. So we have parentheses over here, and inside parentheses we have nothing over here, which means that it has a void inside. Void means nothing. So some programmers, they prefer providing a void inside, which means nothing. Since there was nothing inside, so I did not provide anything inside. So you can write it this way as well, or you can provide a void inside as well if you want, right? So both are fine. both are fine. Void is more readable. If you want to provide more information about your function, it's more readable if you provide void over here. But even if you don't provide void, it's absolutely fine. All right. Okay, so these parentheses, inside the parentheses we have something, and that is called a parameter or argument. We're going to talk about argument in a while, but as in a definition there is one more thing which is called a parameter and argument, and I'm going to come back to it when we write something that requires arguments, right? And then if you notice, there is no semicolon at the end of our function header, right? So there is no semicolon, and I will tell you there is semicolon sometimes, and we will talk about that, but for a while there is no semicolon. Just like you don't have a semicolon for if statements, you don't have a semicolon like this, right? Similarly for while loop, you don't have a semicolon over here, right? So just like these things, functions do not have a semicolon at the end of their header. They don't have that, right? Because this thing is still continued. It's not done, right? And normally when there are blocks, you normally don't put semicolons over here, with some exceptions, and we will talk about those exceptions. So we have created our function. We know what a function is. It has a header, it has a body. What function does is it's a container that contains some statements, and I can use the name of that function to call that function to display those statements, and I can call it as many times as I like, right? Okay, so we have created a function, fine. Now I want to call this function. I want to execute this function, right? I want to call this. Normally it's called, whenever we want to make use of this function in our program, we normally call it, I'm going to call a function. I will call a function. I will send a call to a function, right? Or I'm going to call a function. So when I want to call this function, when I want this function to execute, what will happen is I will just call this function name. I will just call the name of this function wherever I want to call it, right? So let's now say that from our main method, because our program is going to start from line number 13, which is the main method, right? So it's going to start from here. As soon as it enters main method, it will see, compiler will see a display function like this, and compiler will say, I have seen this before, right? I have seen this before. And it will say, since compiler knows everything written over here, what it will do is it will go and search inside this file, which is source.cpp file. It will go and search in this file that is there anything named display, and by seeing this definition, compiler will automatically know that this is a function, right? This is a function, it's not a variable, right? Why? Because it has parentheses at the end. Variables do not have parentheses at the end, right? And whenever you are calling a function, you don't have to specify the return type. So I don't have to do something like this to call a function. No, I don't have to do that. I will call this function. I'm going to return it back to void. So I'm going to call this function without having the return type. So if I'm going to call a function, I will always call that function without the return type. So I'm going to call this function. I want these three statements to execute. I'm just going to call the function by its name with parentheses at the end and a semicolon at the end. This now becomes a statement. This now becomes a statement because I'm just calling a function, and function itself is not a statement. It's just a collection of statements with many other statements inside, right? So if I want to call a function, I will just call a function by the name of that function and parentheses at the end along with a semicolon. If I run my program now, this is what happens. So my compiler came over here, int main. It went inside the main block. It saw something called display and parentheses and semicolon. So by seeing this, compiler knows that this is a function, and I'm going to find that function somewhere in the class, in this file. So it goes up there, it finds display, and then it will come to line number 5, go to line number 6, display hello world, line number 7, then go to line number 8, go to line number 9, then close these parentheses and come back over here to line number 16. After completing the execution of this function, it will come back here and go to line number 16. If there are some other lines, it will execute all of those lines and then come back here. So it will return the control back to the main method, right? Because a function was called from within main method, it has to come back to that main method. after execution. Compiler will come back to the main method after the execution. And I want to show you a diagram very quickly, which is something like this. Okay, so I have a program that starts with the main method. So it has some statements, maybe it has a cout statement, and then there is a call to function, right? There is a call to function number 1. So what happens is, compiler, whenever it sees something like this, it will say, okay, so I have to go and find a function in this file. So it will go and search for that function, it will go to that function, execute all those things, and then it will return to where it was called from. So if this was maybe line number 4 or 5 or 6, it will come back to this line. All right, it will come back to this line, and from there it will go to the next line. It has to go to the next line. Similarly, if there are other calls, they have to return back there, right? They have to return back there. Let's talk about, I'm not going over here for now. Let's go to function number 4. So function number 4, it came here, it was called, compiler will go inside function number 4, execute all the commands inside all the statements, and then it will return back to this statement and execute the next statements after the function, which is the statement, for example, like this, right? So this is how functions work. This is what a definition of a function is, right? So I hope it is clear what a function is, and we can do a lot of things with functions. We can do a lot of things with function. So what I want to do is I want to maybe create an add function that will add 2 numbers, right? Let's do that. We know how to do it, and I'm going to replace this with add. So I'm going to call this add. So your function names, as your variable names, they have to be meaningful, right? Especially function names, they have to be very, very meaningful, because they should depict what this function does. So for example, if I'm going to add these two, they add some numbers in this function, the name of the function should be add, or sum, or total, right? So something like that. If you name your functions x, y, and z, you can do that, but then they will not provide good meaning to, and it becomes very difficult for anybody else, any other program who comes and see your function. He has to go inside your function and read it out to see what that function does. Sometimes functions are very, very complex, and they are hundreds and thousands of lines of codes as well. The functions themselves can be hundreds and thousands of lines of code. So if it doesn't display name, doesn't give an indication of what this function does, it becomes very, very difficult to understand what your function does, right? So what I want to do is I want to add 2 numbers. So what I'm going to do is I will say int number 1, we did this, right, and number 2, and I will ask my user to enter number 1, and I'm going to get this number from user. So I'll say cin number 1, and I'm going to copy this and paste this for number 2 as well, number 2. And what I want to do is I just want to display the result. So let me keep this in a variable called result. So I'm going to say int result number 1 plus number 2, and I'm going to say result is result, and let's do an endl over here, right? So I have created a variable, I have created a function called add. Inside that add function, I have created 2 variables, number 1 and number 2. Displayed something on the console, took an input from the user in number 1, display something on the console, took an input from the user again in number 2, added these 2 numbers and saved the result in result variable, and then just displayed that result, right? Let's run this and see what happens. Nothing happens. What's going on? Is there something wrong with my program? It should display something, right? And nothing has been displayed. Well, nothing will be displayed, because what happened is our compiler started with main method and then it returned. Main method has nothing inside. Although we do have the definition of this function, we have whole function written, but we never called that function. We never made use of that function, right? So compiler came here, it saw nothing inside the main method, it just returned 0, and that's it. So the control was given back to your operating system, and your program did nothing, right? Although everything was written in your program to add 2 numbers, but it was never called. So in order to call that function, I'm going to say this, right? I'll just call the function by its name, putting a parentheses, and then ending it with a semicolon. If I do now, let's see what happens. So the function has, main method has now called the add function. So compiler moved from line number 20 to line number 21. From 21 it will go inside this function. Inside this function it will come to line number 5, see the definition of that function, enter that function, go to line number 7, 8, 9 and so on, right? So it's asking me to enter a number. I will say 5, I will say second number 6, and the result is 11, which is what we were expecting, right? So this is how you can make use of your function like this, and I can call this as many times I want. So maybe I can do something like this just to segregate it. So, and I'm gonna call this function again. Let's see what happens. So let's say 7, let's say 3, result is 10, and then it showed some statics, which means that after this function has been executed, completed its execution, which was the last statement was the result statement, right? And it displayed result over here, and then it came back to line number 22. It executed the next line, which was my statics, right? It executed the next line, and then what it sees is, it sees the function again, call to that function again. So it starts again, it calls that function again. So I will do 4 and I will do 3, and it will display me result number 7, and it will not display me these statics again because it has nothing after that. So it has nothing after that, it will just return, right? So I can call this function as many times as I want, and I can provide different numbers every time I call it, right? I can do that. So this is how your functions make your program more readable. It will optimize your function, it will optimize your code as well, so you don't have to write a lot of lines of code. If I don't have function, I had to copy paste this again and again and again, right, to make this call again and again and again, right? And while loops and if loops, they are not going to work because I might want to do this after doing some statements and then calling it again, right? So while and for loop and any other loop, it's going to do it in one loop, and sometimes my requirement is not that, right? So I hope these functions are making sense now. I'm going to run several programs today, but this is the basic idea of what a function is and how it works, right? So I hope it is clear. I hope you understand what we are trying to do over here. Now what I want to do further is I want to I want to change this and want to add some return statements to this function as well, right? So what I want to do is I want to change it to int, right? I want to do this. Let me just remove these things. Okay, I want to do this int, which means that now I have to use a return statement, right? I have to use a return statement because I said that I'm not going to use a void, I'm going to return something. So what I'm going to return from here, let me return result from here. Let me return result from here. So what will happen now? Let's see what happens. So what happens is everything is same as the previous one. I have a call to the function, and let's see if it displays us something or not. So let's do that. It's asking for numbers, which is fine. What happens is compiler came to the main function, then it went to the add function. It went to the add function. It went inside. It's asking for number 1. I'll do 4. Second number 3. And it added those numbers and it returned that result. But where did it return that result? I cannot see the result. What happened, right? What happened? So the result is returned to the main method. So what happened is it returned something from here, which was the result of addition of these two numbers. It was returned. Where it was returned? To the main function, because it was called from the main function. So the result was returned over here, but I did not make use of that result at all. I did not use that result. So what I'm going to do is I will create a variable. Let me call it addition, and I will save the result into addition. So what will happen now is it will throw me, this method will throw me or return me a result of addition of two numbers, which will be, now this is 3, this is 4, this result will be 7. So it will return me 7. I have to have something where I can save that 7 returned by this function add. So it is going to return me 7, and I'm going to save that 7 in addition, a variable I created in my main method. So I can do that. I can get the results from the function in another function and save them in a variable, which I did over here. So I got the result, I created a variable, and whatever is returned by this add function, I'm just saving that in another variable. Let's see what happens now. So 3 and 5, nothing happened. Nothing happened. Nothing happened because I did not display addition. I did not make use of it. I just stored this value of 7 coming from this method into addition, but I never displayed that value. So I can do something like this. I will say result of addition is, and just like what we do, I will call addition over here. I will do NL and fix this, and that's it. Let's see what happens now. So I will say 3, I will say 4, and now you can see that the result of addition is 7, because now the stored result, I have displayed that result using my cout statement, right? But you not necessarily always have to display your statement. Sometimes you want to keep this result to be used later on for doing some more processing on it, right? So I hope you understand. So what is happening now is I'm not displaying the result over here in this method. I am displaying that result over here in the main method, but I am sending the result to my main method from where I have added that result into another variable, and that variable is being displayed using a cout statement, right? So we can do something like this. We can definitely do this. So maybe we can do something else. So what I can do is, since my whatever result is in addition, what I want to do is I want to increment addition. Whatever the result of addition, I want to add 1 to it, right? I want to add 1 to it. So let's see what happens now. So I can make calculations on that. So let's do 3 and 4. The result has to be 7, but it's 8. What's going on? What happens over here is the addition of two numbers returned me result, which was saved in addition, right? So 3 plus 4, 7. Addition has 7 in it now. But what I did before displaying this addition is I added 1 to that number. So I incremented that result by 1. So what I did is I added 1 to the result. So 7 plus 1 is 8, and I save that in addition. So now when I display the value of addition, I get 8. So I can do some calculations on the variable, on the result getting from another function. So I can do that. I can make some calculations on that as well. So that's how you use return statements, and that's how you use the results of the return statements in another function as well. So let's make another function which is a little bit more useful. So I'm going to create a function that takes an input from the user. We did that. That takes a number from the user and tell us if this number is even or odd, right? So this is what we're going to do. So I'm going to get rid of this one. I'm going to get rid of all of this, and I want to create a function that returns me even or odd. It tells me if it's even or odd, right? So since even and odd is going to be a string, so I can create the return type as string. So let me include a library just to be safe. It will work, but it's always a good idea to include string for doing we might do some other calculations as well. So I'm gonna say name this even underscore odd, and let's do this, right? So I'm gonna take a number from the user, cout, enter a number. I'm gonna take that number in this number variable, and I'm gonna do some calculation on it. So I'll say if number mod 2 is equal to 0, then return even, right? Return even, else return odd. Okay, let's see what we are doing over here. And we are using two return statements. What's going on over here, right? Okay, so we have created a method even underscore odd, and we put the return statement, a return data type to be string. So this function should return a string. All right. Okay, and we have taken an input from the user. User will enter a number. We'll check if that number is even or odd. If this is divisible by 2 completely, then what we're gonna do inside, we will use a return statement and we return a string, and that string is called even. Okay, if it's not divisible by 2, then we're going to return a statement odd. Very simple. So in either case, only one of this will run. Only one of this will run, which means that the function in any case is going to return only one statement. Only one statement, right? It will either return even or return odd. It will never return both of them. It cannot do that. And this is what we said, that function is going to return only one thing. It cannot return many things. Well, it can return many things, but those the exceptions, we'll talk about them later. But right now, whatever data type we have mentioned over here in the return type, it's going to return that thing, and it should return only once. It cannot return many times, right? And this is what we are doing. It will return even for a number that is even, and it will return odd for a number that is odd, right? And what we want to do is, again, I'm going to take a string, I'm going to call it result, and what I want to do is I will save the result returned by this function into that result variable. So result is even underscore odd, parentheses, semicolon. So the result of this calculation will be saved in this result variable inside main method, and I'm just gonna do a cout. So if I do a cout, I'll say result is or your number is result, either even or odd, right? So let's run this code. What happens? Let's see. Oops. Okay, so let's enter maybe 4. Your number is even. Let's run again. 5. Your number is odd. This is exactly what we wanted, and I hope you understand what is going on. So it will return this statement if the number is even, and that even, exactly even, since it's a string, it will be stored in result, and then I'm just displaying that result value. That's it. We can even simplify this code by removing this. We don't need this, and we can just do something like this. Since our even underscore odd is going to result a string, I can use it over here. I can say even underscore odd, and I can do something like this. Since it's part of a statement now, I cannot put a semicolon over here. I'll put a semicolon at the end of the statement, which is over here. So if I do something like this, let's say 4, it will still return me even. So what we did is we have further optimized our code by saving some memory space of creating a new variable. We don't have to necessarily create a new variable. If you don't have to do any calculations and save it, we can do something like this. But if we want to save this information, want to do some calculations on that and then display it, then that's a different story. For example, we incremented our addition variable in our last program. If you remember, we wanted to do some more calculations on that and then wanted to display it. That's why we created a new variable. But over here, we don't want to do any calculation on the return, on the result of this method, so we can use that directly inside our cout statement. Just like if you remember, we did something like this. 2 plus 2 and so if I do something like this, let me put different values so that you don't see it same. So this is what this function is doing and returning over here, and cout, this output stream is capable of doing calculations itself. So 2 plus 2, it will do a 4 for me. I don't have to save this result in a variable and then display on the console. We know this, right? We know this. So we can do something like this as well. So I hope you understand now how we can return something from a function and display that something in another function, right? In this case, a main function, right? So we can do something like this as well. And just to make it simple, you might have guessed it up till now that I can do something like this. And let me change this to display again. And this will not work now because I have removed it, so I have to change this to display now. So if I can do something like this, hello world. What do you think will happen? What do you think will happen? Better pause this video, guess it, and then see if your answer is correct or not. So I'm gonna run it. What will happen is it will just display us your number is hello world, right? Because there was a string over here and we did a display over here, which is actually a string coming from this method. What we did this time is we simply returned a string from here without doing any calculation. So you can sometimes do something like this. I mean, it's not very useful now, but you can do something like this as well. You want to create your own strings, right? We did that, right? So this is how you can work with your data types, return types. This is how you can name your functions, and this is how you can make your functions work. And we already know that we can call one function from another function. We can do that, right? We can do that. We are already doing that. From main method, we are calling a display method, right? Let's do one more thing. What we're gonna do is I'm gonna do a Control Z to get my I hope I can do that many. So I want to get my addition function back. If I can do that, fine. Otherwise I have to rewrite it. So let's see. Oh, yeah, excellent. That's amazing. So many coutts. Okay, so I have created a function. Let's run this. I hope there's no problem. I'm gonna just not do that. And as I said that I can directly call my add function inside this, right? So I can do that, right? If I do this, let's see. I hope we don't have any errors. 5 and 4 is 9. That is correct. So what I'm gonna do is I'm gonna create another function which will subtract two numbers. So by the way, you cannot have two methods the same name. You cannot have that. You'll start having error, and we'll talk about method overloading in a while, but for now these method names in your one file should be unique. Alright, so I have to change this to subtraction. This method will just subtract these two numbers, and I'm not gonna save it in a result. What I'm gonna do is I will do something like this. I will just return this, right? I will do this. I can do that. I don't have to save, just like what we did in cout. I don't have to save this result in a variable and then return that result. I can directly return the result of this calculation. I can do that. So I can do something like that. All right. So this is the short way of doing it. And I want to do something similar over here. I want to return the addition of these two numbers. So this is what I want to do. I have this, and I want to call that function over here. So result of your subtraction is, let's replace it with subtraction method, call subtraction, and that's it. If I run now, 3, 4 is 7. I have to enter two numbers again. 4, 3 is 1. So what happens over here is I can call multiple functions, different functions in another function. I can do that. So I can call several different functions in another function. I can definitely do that. And since main method is a special function, it works like this. But any other function, that even what I have created as a user defined function, I can still call multiple functions inside that function. So let me do that for you. So I'm going to create another function which will display underscore results. So it's gonna just display me some results, and I'm gonna call this, and in this thing, so let me just run this and see what happens. Nothing happened. Nothing happened, right? Because I did not do anything in the main, so I did not call any of the methods. If I call add here, my add function will run. If I call my subtraction function will run. If I call both of them will run. But what I did over here is I created another method, and inside that method I have called both these two methods. So I don't have to call my return and subtraction method in main method. I can simply call this method now, which in return calling these two methods. So I can call display underscore results method, do something like this, and if I do 4 3, it displays 7, 4 3 displays 1. So I can do this with user defined function also. So I can call multiple functions in multiple user defined functions in a user defined function as well. So I can do that. Not necessarily has to be a main function, but obviously main function is the starter function. In order to call all these functions, you need to call some method that calls other functions as well, right? So you can do that. All right. So this is how you can play with multiple functions in C++. This is how you can call functions in the special method, main method, and this is how you call user defined functions in other user defined functions as well. So this is for this. Now in our function, now as I mentioned that functions are just container of your code. You can do a lot of things inside. These functions. So what I want to do is I'm going to keep these functions because I might need them, but I'm not going to call these functions. So what I want to do is I want to display even numbers, display even underscore numbers. I'm going to display even numbers, and let me call it numbers as well. Even numbers. Okay, so inside this what I want to do is I'm gonna run a loop, and I'm gonna display even numbers from 0 to 20. Yeah, very simple. This is what I want to do. So just want to tell you that you can use any type of code inside your method. So you are not bound to anything, right? So I can run if statements inside my function, I can run loops inside my function, I can call other functions in my function, I can do almost all the things I can do in main method, right? So what I'm gonna do is I'm gonna display all the even numbers between 0 and 1. So into I of 0, I is less than 20, I plus plus. Let's do this way, otherwise it's very simple if I do two additions over here. Or okay, let's do it the right way. Okay, if I mod 2 is equal to 0, I will do a cout of I. I'll do a tab /t, and that's it. And that's it. So it's going to display me even numbers from 0 to 20, excluding 20. I can include 20 as well if I want. So you can do anything with function, anything inside the function that you can actually do in the main function. So you are not bound to do something very special that can happen only in main function. You can do all those things in any other function as well. So this is how your functions work. This is how you can provide return types to your functions. This is how you can use the functions inside, and you can do a lot of things inside the function. Okay, what I'm going to do one more thing is let me take this function and put this after our main function. Alright, so I have done something like this. Let's run it now. Error. What happened? Let's see. It says that display number identifier not found. So compiler is complaining now that I cannot find this function anywhere. I cannot find anything here. Why? Because main method is written before that function. It's written before that function. So compiler will start at line number 28, which means that compiler knows everything before line number 28. But it doesn't know anything after line number 34, after the completion of main function. It doesn't know anything, right? So if I write functions like this after the main method, I'm going to get a complaint from the compiler saying that I don't know what you are talking about because I have not seen this function anywhere. So that's a problem, right? That's a problem. So I have somehow declared it over here, but compiler doesn't know about it. So in that case, what we can do is we can simply tell compiler that there is a function by this name. Let me first run it, and then let me tell you what's going on. It ran fine this time. It ran fine this time. What I did over here is I have just put the signature of that function, just the signature or the header of that function with a semicolon over here. I just did that. So I copy pasted the header with a semicolon over here. What happens now is, so compiler starts here. Compiler knows everything before this main method. It doesn't know anything about anything happening after the main method, right? So compiler will see this. Compiler will say, okay, it means that there will be some function by this name, by this header somewhere after main as well. So what compiler will do after seeing this is it will keep a track of all of them above that before the main method, but now compiler has a definition of a function which is before main. If you put this definition after main, it will still not work, right? So you have to just put the header of that function over here, telling compiler, please do look after the main as well for this method. Please do look for this method after the main as well. And it will go and see the functions after the main as well. So sometimes, not necessarily, your function has to be before main, because sometimes programmer wants to make their program readable in such a way that main method is the first function. They put main method first and then everything after that, so that whenever some programmer comes, at least they know where to start from, what is the flow of the program. So so they go as they call functions inside the main method. So for example, they are calling display even number first, then they are calling add, then they are calling subtraction. So this is how they're going to place their functions. They're going to have a main method at the top, then display function, then add function, then subtraction function. But if you don't specify the header, compiler will not know that something like this exists, right? So it's always a good idea to have a way of writing a program from beginning. So if you want to always put your main functions or your functions, traditional user defined functions before main method, fine, you can carry on with that. But if you want to put main method before, then there is, I told you, a way of telling the compiler how to find that after the main method, right? So this is how our functions work. This is how we make our functions work for different conditional statements as well. We know how to return things. We know how to get those things in the main method or any other method, and we know how to utilize them now. All right, let's talk a little bit about parameters and arguments now. We have seen the header, we have seen the body of the function, we have inside the header, we have seen about the return type of a function, the name of the function, we have seen the return statements as well. The only thing right now remaining for functions is the parameters and arguments. If you go back to our function, you can see that there is either a void inside or nothing inside, right? So void means nothing inside. So we can also provide arguments inside. We can provide some numbers inside. We can provide some strings inside, or any other thing you want, any other data type you want. So we can also provide functions, by the way, here, and we will talk about functions in our last lecture as well. So we can make our program much more efficient than this. If you see right now what's going on is, if I run my program, let's see what happens. So it's just displaying even numbers. What I want to do is I want to go back and I want to change this to display results, and I want to use these two statements of cout result is, and I'm going to call an add method here, and I'm going to call a subtraction method here. So subtraction method here, and I'm going to change this to display underscore results. Oops. Display underscore results. Okay. If I run this code now, what will happen is I will do 4 and 3 7. I will do 4 and 3 1. So let me put an endl here as well, just to make it more readable. So if you see over here, what is happening is I have to take input twice, right? So what is going on over here is I will do 4 and 3, it will show me result 7. Then it's asking me to enter the numbers again, 4 and 3, and then result is 1, right, which is a subtraction of 4 and 3. And it's asking me to input these numbers again and again. So I have, if I have another function multiplication, and I put this logic in multiplication, replacing this with static sign over here, it will definitely give me the right result, but it will keep on asking me to enter those numbers again and again. What if I want to enter these numbers once and then I want to see all the results, right? It will be much more comfortable, it will be much more user friendly, right? So for that, what we can do is we can use arguments. So what I'm gonna do is I will take all these things into the main method, or I can take it here also. Let's since this is display result, let's start with doing here. So I can take this over here, and once I take it over here, I will remove it from here as well, since I want to call these numbers, get this input only once. I don't want them to be entered by user again and again. It's not user friendly at all, right? So what we can do is we can because this, if you see this code was exactly similar in both subtraction and addition, so it doesn't make sense writing the same lines of 4-5 lines of codes again and again, copy pasting that again and again. And it's actually not good programming practice, because we are creating our methods to optimize our code, and then we are copy pasting inside our method, so it doesn't make sense, right? So what we can do is we can use parameters to solve this issue, right? What is a parameter? So let's talk about add first of all. If you see now, once I remove those int number and int number 1 and number 2, I start getting an error over here, because this method will say what is number 1 and what is number 2, because these variables are not defined inside this, right? So it doesn't know, add method doesn't know what number 1 is, what number 2 is. Same happens with subtraction, number 1 and number 2, it doesn't know about those, because those numbers are declared inside result, and these methods cannot share these variables. I'll talk about how they can share the variables in a while, but for now they cannot look these numbers, so they don't know about these numbers. Either we define these numbers inside them, each one of them, what we did earlier, so we have to copy paste all of them together over here again in this one and in this one, but then it will be repetition of function. We can avoid this by changing the header of our function, and this is how functions are normally used in real world, right? So what you have to do is, I need two numbers, right? I need to add two numbers, so I need number 1 and number 2. So what I will do is, inside this bracket I will do int number 1 comma int number 2, right? You will see that error has disappeared now. Error has disappeared. Same thing I can do it for this one, number 1 int number 2. I can make them anything. It can be A, B, but then I have to change A and B over here as well. So what this function does now is, it takes some arguments, some parameters, add these two numbers, add those two arguments, and return the result, right? So now I don't have to have this, right, inside this, because I have overcome the error. There was an error, I have taken care of that error, so there is no error. So these are called arguments. These are called arguments or parameters of a function. So I can input numbers over here, and those numbers are taken here, and they can do some calculation on that, and then based on the return type I can return that. Let's run this and see what happens. I'm going to get an error, right? I'm going to get an error, and let's see where that error is. So let's double click this one, too few arguments in function call. So I'll double click this. It's saying that you have an error at line number 22. It says that add error. So what does it say? Too few arguments in function call, which says that the definition of the function you called here is different from the definition of a function you created over here. in this function you are saying that there is void inside, there is no argument, but then in the function call, in function definition you have two arguments. So compiler is telling me that either these two functions are different or I don't know what you are trying to do, right? So what I want to do is I want to match this definition for this function. So whenever I'm calling a function, the definition of the function, this header of the function should match its actual function. So I have to provide the same numbers here. So I will do number 1 here, since it's two numbers in two integers, number 1 and number 2. I have to provide two integers here. So I will say number 1 comma number 2. Let me put a bracket here. And where these numbers are coming from, they are coming from these. I have already declared them in this variable, in this method over here, taking that numbers and passing this over there into this function. I will do the same thing for subtraction. Number 1, number 2. And let me run this code and see what happens now. Oops. Okay, so let me enter 4, let me enter 3. Now you can see that it showed me the result. Result is 7, which is the addition of these two numbers, and result is 1, which is the subtraction of these two numbers. So I have actually fixed the problem by entering those two numbers only once and making different calculations using different methods through this method. Now let's see what happens. What actually has happened? Let's see that. So our main method was called by the compiler. Then compiler went inside, it called this method display result, so it came over here in line number 14. Then it went inside, it created a variable number 1, then it created the second variable number 2, it displayed something to the user, took input from the user for number 1, took another input from user in number 2. Then what it did is it called, so it's on line number 22 now, and then it called this function add and passed these input entered values by the user inside this function. So it said number 1 here, number 2 here. When compiler sees this, compiler will go from line number 22 to the definition of this function add, which is at line number 5. So it will go there. Now number 1 is what? 4, because user entered 4 here. Number 2 is what? 3, since user entered 3. We are assuming user entered 4 and 3 over here. Now number 1 was 4, which was entered here. Number 2 was 3, which was entered in second argument. This whole thing saying add 4 comma 3, compiler took them over here and went over there. So now in add, compiler had 4 and 3. So number 1 contains 4, number 2 contains 3. It will just add 4 plus 3 and return that result, and that return, and once this result is returned, it will be returned on the same line number 22, and instead of add number 1 number 2, now my result will be displayed, which is 7, right? Same thing happens over here for subtraction. So it took numbers 4 and 3 again. For example, number 1 is replaced by 4, number 2 is replaced by 3, and compiler will find now where the subtraction is. So it will find subtraction at line number 9. It will go for subtraction 4, 3. It will do 4 minus 3 and return the result. That result is returned back to the same line, which is line number 23. Now subtraction 4 comma 3 will be replaced by 1, and it will display result is 1. So this is how you can pass arguments to your functions, and this is how your functions can work with some of the arguments. Now these arguments not necessarily had to be same values. I can do this, for example, I and j. I can do that, and I can just replace this with I and replace this with j. I can do that, and it will still work. It will still work. It doesn't matter what is the name of your variable inside. It doesn't matter what the name is, as long as you are not misspelling the name. It doesn't matter. 4, 5, for example, 9 and minus 1, right? So it doesn't matter what the name is. These name, this name and this name, they don't necessarily have to be same. This name inside and this name inside not necessarily have to be same, but this name and the usage of this name, they have to be same. So the numbers you are using in the header and inside the function, they have to be same if you are referring to these integers, right? The only thing that is required to be same is the data type. If you are passing inside this function an integer, it has to be an integer here. If you are passing a string over here, it has to be a string over here, right? So you have to make sure only the data type is same when you are passing things over there, right? So you can do something like this. You can do something like this. Now what I want to do further is I want to okay, so I want to keep this because I don't want to write it again, but I hope you understand that how passing arguments can help us. So what I want to do is I will do one more thing. I'm not gonna call this. I'm gonna create another function. I'm gonna call it even and odd. So let me call it string, and I will change it later. So yeah, so let's do that. Is even, is underscore even. So what this function will do is it will tell me if my number is even or not, right? So let me write and I want to get this number from main method. I want to get this number from main method. I don't want to take input from the user inside this function. I want to take the input from user in the main method, so that I can use it somewhere else also, that input. I don't have to take that input again and again, right? So I will say int number, and I will just use that. If number mod 2 is equal to 0, then I will just return even, just like what I did before. Else I'm gonna return odd, right? I will do something like this, right? And over here I want to take an input from user, so I will do int maybe input. I will do cout, enter a number, cin input, and I'm going to call that function, right? So just like what I did before, I will do cout, and I will say your number is whatever I want to call it. I'm gonna call it what's the name of the function, is underscore even, and I will do an end over here. Now I have done this, right? Now I have to pass a number inside it, because the definition of this function over here and the definition of this function over here, they are different, right? So I have to make sure their definitions are same. So this actual function is saying you need to input a number inside as a parameter, and I have not provided any parameter here. So I will put input over here, which number I am taking from here. If I run this now, it will ask me for a number, and it will say your number is even. Perfect. If I do 5, your number is odd. Exactly, this is what I was looking for, right? So you can do something like this as well. You can have a different data type as a return type, and you can have different data type as integers. So you can do it separately also. Not necessarily they have to be same. Not necessarily have to be same, right? And one more thing, since I intentionally put the name of this function as is even, so it should not return me odd. It should tell me if this is even or not. Whatever number I am putting, is it even or is it odd, right? So what I can do is I can either do something like this, true, or yes. Maybe I can say something like this, yes, for example, and I'm gonna make it better, and I'm gonna say this result is something like this. Let's see now. So result is yes. Enter a number, because I want to tell if my number is even or not, right? So if I do something like this, we know that this one is going to result no, and it makes sense. This is what I wanted to do. I want my functions to tell me if the number is even or not. I'm not saying that it's going to tell me even or odd number or something like that. Why I'm telling you this, because I might have something similar in lab exercise. So that's why I want to tell you that how to do it, right? So this is telling me that there is a function that is taking some number and it's telling me that if that number is even or odd, right? So it's telling me that. Right now if you see, I'm returning a string here. I'm returning a string here, right? I'm doing like this. I'm returning a string, right? So this is a string. But for yes or no, for 0 or 1, for true or false, we have a special data type. It's called Boolean. It's called Boolean, B-O-L, right? It's Boolean. And when I do something like this, I don't have to do this. I can do this. True, these are keywords, and false, like this. So I can do this because this is even means it's either yes or no. It's a binary one, right? It's a binary or a Boolean value. A number would be either an even number or it will not be an even number, right? So only two possibilities I have. For something like this, you use a special data type in almost all the programming languages, which is called a Boolean data type. So I can do something like that. Let's see what happens now. If I do 4, it says result is 1. It says result is 1 because the number behind true is 1, right? Similarly, if I do 5, it's an odd number, which means that else statement worked, which says that it's false. So it says that result is 0, right? So it's telling me either it's an even number or an odd number, right? It's telling me that. But this, if you show this output to the user might not understand what is this, right? User might not understand this. So in order to make it more user friendly, you normally don't return zeros and ones to user. You normally return in plain English or any other language what the result actually means. So from this 0, what should user say? Because it doesn't say anything over here, right? So either you say that, say on the top of this program, that if 0 is returned, then it means your number is odd. If 1 is returned, then your number is even. Either you mention that clearly to the user or you do something more readable, right? So what we can do is, after returning these values, we can even use these values to check something else. We can make more calculations on these values. If you remember, when we did addition plus 1, so we added a value to the result. So we can also check our we can also do more calculations with this. So since it's returning a true when the number is even and returning a false when the number is not even or odd, so I can do an if statement here to make the output statement look better. So what I can do is, if this is the name, if is underscore even and input, if this is the one, I will display cout your number is even. I can do something like that. Else I can say your number is not even, right? Or odd, or whatever you want to call it. So if I do something like this, if I do 4, your number is even. So this is much more readable to user. And if I do something like this, 5, it says that your number is not even. It's much more readable than providing binary values to user, zeros and ones. So what I did over here is, I've actually used the output of this, or the return type of return value of this function in an if statement. In an if statement, I could have done something like this. I could have done bool value and do something like this, and then use value inside, and then run the code again. So I will do 5, your value is not even, and similarly if I do a 2 over here, your number is even. Yeah. So what I am doing over here is, I am saving the value, return value. I am saving the value returned by this is even function in a variable called value, which is a Boolean type variable. Why? Because I am returning a Boolean value. So only Boolean value will be able to save this. Well, we can save it in other variables as well, but it's always a good idea to save the return type of, save the value in the same variable with the return type, right? If it's a Boolean, then you save a value in Boolean, right? Now Boolean contains either a true or a false, or it contains a 0 or a 1. In the back end, it's 0 and 1, right? So false is 0 and true is 1, right? So now this value contains either a 0 or a 1 or a true or a false, right? So let's go with true and false, since we are returning true and false. So we now have value over here corresponding to our number, right? So if we entered 4 over here, value contains a true here. So I have used this value inside my if statement. I can say if value, and this will only work if this statement is true, right? If this statement is true, only then it will go to this block. And if it was a 4 over here, 4 is an even number, it will return a true, right? So my value will contain a true inside. So if true, which is true, it will go inside this block and run this. If it returned false, my value will contain a false here. If false, which means that this condition is false now, it will not go inside, and it will go inside this else statement, and it will display this. So I can do something like this, or like what I did previously with functions over here. I don't store them in a separate variable. I can directly use them inside my statement. So I can do something like this as well. I can do something like this. So I can directly use this in the if statement. So the result of this return statement will be used by if condition. So I can do something like this, right? Just like what we did with our method. So I will do a 7 over here, and it will display me the result. So I can do something like this as well, right? So I hope it's making sense to you now. So we can use a different data type like Boolean, also providing a different data type inside our parameter. So they are two different things all together in a function, so they can be different with each other. So I hope this is making a lot of sense to you. And this is how we can manipulate our functions. They are extremely important. They are very important. They are very powerful, and you can do a lot of things with them. So many things you can do with them. With functions, with small functions, you can achieve so many different things, and you will see when you work on programming languages that how powerful functions are, and how your main method is normally few lines of codes. The rest of the things are either in your classes or inside your functions. Normally in majority of the bigger projects, main method is only few lines of code. Sometimes it's only 4 or 5 lines of code. Rest of your code is either in your classes, which we will talk about maybe later in the course, or in the function, right? And this is how you manage, and it's very readable. It's very readable. Add means it's gonna take 2 numbers and it's gonna add 2 variables. Subtraction means subtracting 2 variables. Display result means displaying some result. And is even, very readable. It's going to tell us if this number is even or odd. So very simple, very easy, very readable. So this is how your functions work, user defined functions work. And I think we have gone through few of the exercises. This we have already done, displaying something. You can do this. We can pass a message to our function. In fact, let me write this quickly for you so that you can understand what's going on. So let me create another function. I'm going to get rid of this. And very simple one, just to display a message to you. You might already know this. So what I'm going to do, void display, and I'm going to pass something inside. So I'm going to do string message. And I'm going to just display this message. I'll do a message and this one, and I'm going to call cout. I am inside the main method or main function, and I'm going to create a variable. Let's call it maybe str for string, and I'm going to call it I am inside the function, right? And oops, it's not int, it's string. and what I want to do is I want to call this method and pass this variable to this method. Okay, so this is what I'm going to do. So I'm going to do display, and inside this I will just pass this variable. Now let's see what happens now. So it will just display two methods. So first of all, it came to int, it ran line number 46, it displayed I am inside the main method, which is displayed over here. Then we created a variable, string type variable. I mentioned I am inside the function, and I have passed this variable inside this string method, which means that when compiler sees display and string inside here, it will search for that method over there. So it will go to line number 38, it will just do cout message. Message was what? This was what I have passed from here in the form of string here. So this is passed over here, and it displays this message over here. I can do this directly as well, as I told you earlier. So I can display this directly over here as well. So I can do this as well. Close this. And I can directly do this as well, and it will run as well. So this is how you can work with your methods differently. Very simple method. I'm sure you might have already guessed what I have done. So this is how you can work with methods as well. What else we have here? We have added two numbers. We have already seen this, right? We have done that. We have done this as well, adding two parameters and then returning a value. We have also returned the Boolean value as well. Try to do this function for yourself and see. We can return a value like this as well. So I can do something like this as well. Let's keep it void maybe. I can do a return. I mean, I have already shown you this when we return even and odd, right? So I know that we have done this before. So an execution of the function, we already saw this. A function can call another function as well. So for example, from main function to main function, function 2 was called, and function 2 called further function 3. Then when returning from this function, function 3 will not return to the main function. It will return from the function that has called this function, which is the function number 2. So function 3 will return to function number 2, and function 2 will return to the main method, right? We have done that. We have seen this, that function has a name, it has a return type, it has some parameters and data type of different parameters. So we have seen this, and I have shown you. We have done this as well. We have done these, and we have done something like this as well. Yeah. Now we have to talk about local and global variables. Very important concept. It might confuse you if you don't know what a local and a global variable is when you are writing some methods or some programs. So it's very important you get to know what a global method is, what a global variable is, and what a local variable is. I'm gonna clean this up just so that you don't have confusion. So I have a very clean slate over here. What I want to do is let me create a function maybe. So let me create a function void test underscore function, and what I want to do is I will create int number 1, and I will do cout. Let me not do cout very quickly, I'm just going to take a shortcut. I will just assign it a value and display this value, right? So I will do this, and I will say number 1 is inside the function is, I'll just display the number, yeah, and done. I'll do this. I will create same name variable in the main method as well. I'm gonna give a value 6 to it, and I'm gonna do the same thing over here. And after doing this, I'm gonna call this function test underscore function, so that this code also runs. If I don't call this function, the function will not run, right? It will just stay there. So I have to call this in my main method. So I will do this, and I will do this. Pause the video and test your knowledge by predicting the output of this function, and then you can run the video again. So I'm going to run this video now. If you see, what happens over here is it displays first of all number, I it has to be main function. Inside the main function, I have to run it again. So let's do that so that it's much more clearer. So it first displays number 1 inside the main function, and the value of that function, that variable is 6. Then it displays number 1 inside the function is 5. So number 1 inside the function is 5. Why I did that is because I want to tell you the scope of the variables, So if you see, I have created a number 1 inside this, and I have created a number 1 inside this function as well. They will not change the value of each other, because this variable is accessible only in the main method, and this number 1 is accessible only in the test function. I cannot use this number 1 somewhere in the main function. No, I cannot do that. They are separate variables. Although their names are same, these are separate variables, and their scope is inside those functions only, right? So these are called, so if I talk about this is called a local variable. These are variables local to their functions only to their functions. They cannot work outside in any other function. They cannot work on that. Although they have same names, but they have different values, right? So they can work within the scope of their methods, of their functions. They cannot work outside the functions. This is called a local variable, and this is called the local scope of a variable. Which means that this variable, I cannot use this outside this bracket. After this bracket, I cannot use that. This can only work inside this block. This can only work inside this block, right? Now, sometimes it doesn't work like this. I want to have a function. I want to have a variable that I want to access everywhere in my program. For example, in this file. So I want to have that function be accessed over here. So because I don't want to create it again and again. I don't want to do that, right? So in that case, what we can do is we can use global variables. So let me remove them. And in that case, what I can do is I can define them at the top. Before any function, before any main method, I'll define them over here next to my namespace and libraries, right? Now let's see what happens. If you see there is no error, it means that this function can easily access number 1, although number 1 is not inside. Main method is not complaining about this number as well, because main method can access this number 1 inside the main method also. So let's run this code now. It's displaying 6, both of them displaying 6. So it means that this function can access this variable as well. Main method can access this variable as well. This type of variable is called a global variable. This is called a global variable. It is globally available for all the functions throughout my program. I can access this variable anywhere I like, no problem at all. Then you might be thinking, we should always declare all our variables globally, right? We should declare all our variables globally. They shouldn't be inside any function, right? No, it can create a problem. Right? Why it can create a problem? Let's see why. Okay, so what I'm gonna do is I'm gonna change the value of number 1 to 3 inside this function. Okay, and let's see now what happens. Okay, let me just call this function first, test underscore function, and let's see now. Okay, now if I run this, what happens is number 1 inside function is 3. So number 1 is 3, and number 1 inside function main is also 3. Now what happens? Main was actually expecting this 6 value of the function, right? Main called this variable number 1 expecting that, okay, the value of this function, this number is 6 because it is defined globally. But somewhere during the execution of test function, it changed the value of number 1 to 3. Now a main function was expecting this value to be 6, but since test function was working on this variable as well, it changed the value to 3. And the result which main got is totally different than what it was expecting, right? What it was expecting. That's why global variables can be very, very dangerous, because some functions are expecting something else from those variables and they end up getting some different results. So although you can still use the global variables, no problem, but you have to be very, very careful when using those global variables. You have to be very, very careful. A lot of programming languages still provide global variables. It's a big debate that global variables should be there or not, but they are still there for most of the programming languages, as there are definitely some advantages of global variables, but they can be very, very dangerous because they can spoil the whole logic. For example, you have thousands of lines of code, right? And you have defined a global variable over there, and you have to keep track of the value of that global variable throughout those 1,000 lines of code. It doesn't make sense. It's very difficult to do that. Imagine you are debugging a 10,000 line of code and you have to take care of this number wherever you go, right? But if you are within the functions, you at least know that the scope of that variable is within that function, so you can always go back to the start of that function and you can work on that, right? But if you have to take care of that function because you have done a global declaration and some other function comes and changes it, then you might get some unexpected results. So that's why global variables can be dangerous when you are working with them. Just make sure that if you are defining a global variable, you have a very, very solid reason to define it. Otherwise, local variables are best to go. Okay, so this is what a difference between a local and a global variable, and we have discussed that, and actually we have done that as well, right? So we have done this as well. We have talked about local and global variable as well. Normally, I mean, one thing I should tell over here is whenever you have a global variable, you should initialize it with something. Don't leave your global variables like this. It's not a good idea to do that. Not a good idea to use global variables, and if you don't even initialize, then this is even worse, because you don't know what will be the initial value of this, and some function will define it to something and then another function will try changing that. So at least by defining the initial value of a global variable, you have at least some understanding of what that value of global variable is. So just make sure that you understand carefully what you want to do with global variables. Just make sure you understand them carefully. All right, and these are global variables. I would suggest you guys to work on these programs. It's something very similar to what I did. Just try to do that and try to understand what it does. I'm gonna leave this to you guys, static local variables. I want you guys to try this on your own. What I really want is not to explain every single concept to you guys, because I know I keep on doing it and you might not end up doing that thing. So I want to leave at least one thing for you guys to practice, to go and search for it, because if I provide you everything, then the research aspect of this course will go wasted, right? Because one of the outcomes of this is you guys do something on your own. So I'm going to leave this static local variable to you. I have defined everything to you. It's just a very small keyword of static. You just do some research on what does this mean. It's a very simple line of code. So you just try to see what you can do with static. All right. So that's with local and global variables. We are done with that. I'm going to move to the next topic, which is overloading, function overloading, and we're going to work on that. All right. So function overloading. What a function overloading is, I'm going to just clean this again so that we have a clean slate again. Function overloading. Okay, let me do a function overloading first and then explain what that is. So add int number 1, number 2. I'm gonna add them. Oops, int. I'm gonna return the addition of these two numbers. That's good. I'm gonna use this again. I'm gonna do add. I'm gonna add another number. And I'm gonna add another number over here. And let me do once more. So I will do another one. Int number 3, comma int number 4. Number 3 plus number 4, and let me call it let me call with 4 and 5, and I'm having an error because my return type, I'm returning something and I put this as void. It should be int for all of them, int and int. Alright, okay, and I have to put a semicolon here. So let me call this function again. Let me add a 6 here, 6 and a 7 here. Let's run this code. You will not see anything, right? Let me explain this to you first of all, and then we'll see what's going on. Okay, or let me just display this first of all. So let me do a cout so that it will be easier for me to explain. 2 arguments, result of 2 arguments, and I'm gonna do the same thing for the rest of them. Result of 3 arguments and result of 4 arguments. Okay, let's run this code and you will see some results, and okay, let's run this. You will see that I have a result of 2 arguments, 9, adding 4 and 5, then adding 4, 5 and 6, then adding 4, 5, 6 and 7. I have these results. Now if you see over here, what I have done is, this is what we have done in our previous program as well. So I have created a function called add. I've taken 2 arguments, number 1 and number 2. I have added those 2 numbers and returned the result because my return data type is integer. If you remember, I told you cannot have the same name for the functions. Your function name should be unique, otherwise you will get an error. But over here I have 3 functions with the same names and still working, right? Okay, it happens to be you cannot have same function name with same parameter type. Sorry, same number of parameters. All right, so this cannot be same. So if I do int add int number 1 comma int number 2, and then I will do int add int number 1 number 2, and then do it again, I will get an error. If you see, what is happening over here is the name of the method is same for all these 3 functions, 3 methods, but the number of arguments, number of parameters inside, they are different. We have 2 arguments here, we have 3 arguments here, we have 4 arguments here, right? So the name of the method, return type of the method is exactly similar, but the number of arguments are different for each method. This is called method overloading. So I have overloaded the same method with different parameters every time I created a new method. So this is called method overloading. Now if I want to add 2 numbers, I will still say a method add, right? If I want to add 3 numbers, I will still call that method an add, right? If I add 4 numbers, I will still call that method add, right? So I cannot keep on changing the name of that method just because the number of arguments are changing. So sometimes in your real world projects, you need that. You want to keep the name of the method same, exactly same. But then C++ would not allow that. So in that case, what you can do is you can change the number of arguments inside, right? You can change that. So this concept is called method overloading. Similarly, if you have something like this, let me call it maybe float, and I will call it float, I will call it float. Even this is method overloading. Although the number of arguments are same, but the data type of number of arguments is different. This is also called method overloading, and C++ will not complain about it because the header is different. At least this part is different, right? Similarly, if you do add and you add to double numbers, C++ will not complain again because they are two different methods. Although the name of this method is same, but the signature of this method is totally different. So this concept is called method overloading, and you will use it a lot in market when you go to the industry and start working on different programming languages. And almost all the modern programming languages, they offer method overloading. All right. So this is one more thing I wanted to tell you. You can still use the same name of the method, but you need to use different arguments, right? Either the number of arguments should be different, or the data type of the arguments are different. All right. So this is one more thing I wanted to tell you, and I think that's pretty much it from today's lecture. If you remember, we did something like this: include cmath.h, I guess, if I'm not wrong. Is it cmath? Only math. Yeah, only math. Okay. Cmath is for C language. Okay. So, and we used a square root method, right? We used, if you remember, we used something like this: sqrt of, I don't know, 4 or whatever, right? So if I do something like this, if you see, this is also a method. This is also a method. It has a name, then it has parentheses, and inside this I'm passing an argument. So this is also a method, and this method is called a built-in method, or pre-packaged methods, pre-processed or pre-packaged methods, or built-in methods, or library methods, right? So this is available inside this library, and you can use that. So you will find methods everywhere. I mean, your C++ program starts with a method, int main. So methods are available for you to be used. They are inside the libraries as well. You can use a lot of libraries that have methods inside them, and you can use them to get your desired output. If something is not available there, you can create them, of course. You don't have to sit back for somebody else to create it for you. You can create it on your own, and you will use methods a lot. I'm sure people who are already working with the different programming languages, they are well aware of methods and functions, and they know their importance, and they know that it's almost impossible. It becomes almost impossible to work with functions when you are writing a very lengthy code. So that's how functions work. This is how different operations can be performed using functions. This is how different functions can call other functions. This is how main method can work with different functions. And we have talked about method overloading as well, or function overloading, or overloading of functions. We have also talked about local and global variables, very, very important concepts. You should know that. Try to see this hide and shadow. I have not done this for you, but try to do this and see what it means. And static variables I have left for you. Try to do that as well for you yourself. You guys need to understand what these things are. And that's pretty much it for functions. I think we have spent good time understanding what functions are, how they work, what they do, why we use them, how they are useful. We have done a lot about functions. That's it from my side. Just to tell you that we are going to have a lab session this Friday, 8:30 a.m. to 9:30 a.m. in the morning PST, and I'm gonna give you a task that is related to functions. So please go through this lecture carefully. Do different variations of what I gave you. Try to do different variations, and we know how we are going to conduct our lab session. So Gurjeet is going to be with me, and we are going to ask you questions, picking up random students, and you will get a text file, and in that text file you have to put your code. I'm going to explain that during the lab session as well, but I don't want to spend a lot of time again, because I want to give you guys more and more time to solve that question instead of me taking time explaining the question for you. So please go through this lecture, try to make sure that you understand what functions are, how they work, what are different variations of functions, so that you are able to work on the task I'm gonna give you in the lab session. So that's it from my side, guys. Have a wonderful week. I'll see you during the lab sessions. Bye bye.